If we're interested then in factors with real coefficients or in the real zeros of a polynomial, it's important to be able to decide if we have a quadratic that we haven't been able to factor, whether it can be factored with rational coefficients, we just haven't found them yet, or it's prime, so it has real factors but not rational factors, or if it's irreducible, so there's no way to factor it with real coefficients. Fortunately, we already have the tool that we need for that. That's the discriminant. Remember, if we have a quadratic equation, ax squared plus bx plus c equals 0, the discriminant tells us how many real zeros that polynomial has, how many real solutions that equation has. And of course, the factors of the quadratic correspond exactly to the solutions of that equation. So in terms of factoring then, if the discriminant is a perfect square, then the quadratic has factors with rational coefficients. If the discriminant is not a perfect square but is a positive number, then the quadratic is prime, so it can't be factored with rational coefficients, but it has factors with real coefficients. And finally, if the discriminant is negative, the quadratic is irreducible, so it cannot be factored with real coefficients. So, given a quadratic, we can determine whether it's factorable with rational factors, prime, so any factors have irrational coefficients, or irreducible, so it can't be factored even with irrational coefficients. And to do that, we just need to calculate the discriminant. So here we have x squared minus 6x plus 4, right? So a is 1, b is negative 6, c is 4. The discriminant is negative 6 squared minus 4 times 1 times 4 is positive 20. Now, 20 is positive, but not a perfect square. So this polynomial is prime, but not irreducible. Next, we'll consider x squared minus 6x plus 8. So a is 1, b is negative 6, c is positive 8. The discriminant then is negative 6 squared minus 4 times 1 times 8. That's 36 minus 32 is 4. And not only is 4 positive, 4 is a perfect square, right? It's 2 squared. So this polynomial is factorable. It's possible that you may have looked at that and immediately seen that it was factorable. If you immediately see how to factor, of course, you don't need to check the discriminant. If you know what the factors are, you know that it's factorable. Okay, our last example, x squared minus 6x plus 13. We have again, a is 1, b is negative 6, c is now 13. Our discriminant then is negative 6 squared minus 4 times 1 times 13. This is going to be 36 minus 52 is negative 16. And of course, negative 16 is negative, and so this quadratic is irreducible. So just by looking at the discriminant, we can tell whether our quadratic is prime, but not irreducible, factorable over the rationals, or irreducible.